Section 6.2, problem 6, 7, and 8. Here's number 6. It tells us to sketch the area under the normal standard curve, that's the z-curve, over the indicated interval and find the area. Round to 4 decimal places. Let's draw this curve. Oh, I don't know why that is so thick. Anyway, we'll make it do. There's the normal curve. Now we want to go left. Right now the high point here is 0. We want to be to the left of negative 1.43. Negative 1.43. That's what we're looking for out here. What is that area? Now we're going to use our calculator. The examples might be using the textbook, the table in the back, but I think we're going to use our calculator because most people will do this in practice using a software package or a calculator. So on your calculator, here's what we're going to do. If I can do it, I can't get a smaller font here. I don't know what happened. Anyway, I'm going to press second and then VARS. And on top of VARS, that's where distribution is. So second VARS. Now choose item number 2, which is normal CDF. Now what comes up is lower, upper, mu, and sigma, and then paste. I can't get this font any smaller. Now what we want to do, our interval is going here, right? Here's our interval. It goes all the way this way, right? We're going all the way that way, all the way out here. Well, that's negative infinity. Now the calculator way of saying negative infinity is negative E 99, which means something like negative 10 to the 99th, all right, really small number. So how do you get it? How do you get that? Well, let's see. What do? You press the negative sign. All right, so to get this, you're going to press the negative sign. Now, that's at the bottom right. So press the negative sign, right? That'll get you that negative right there. Not the minus. Has to be the negative sign. Then, right above the 7 key is a key with a comma on it. Right? It's a comma key. And right above that is EE. So you have to press second, because it's a second feature, it's a blue feature. So press second and then the comma key. Now when you do that, you get only one E. Even though it says EE, you get only one. Then type 99, right? So here's what you're going to do. You're going to press, what are you going to do? You're going to press negative, all right? So go to the negative key, press negative, then go to second, then the comma. You only get one E, and then type in 99. That's essentially like negative infinity. All right, and then for upper, what do we want for upper? Well, upper is our upper limit, negative 1.33. So put in negative 1.33, negative 1.33. Oh, boy, okay. 1.3, no, it is 1.43. Okay, this fat font I can't fix. All right, and that's a negative sign, right, not a minus. Now, the mean here is 0 because it's the normal curve. Standard deviation is 1. So go to paste, all the way down, go to paste. And when you press paste, what you get is, well, you can't really see it much over here on the left. All I can see on mine is like an arrow, and then I see that E99, negative 1.43, 0, and 1, and a comma. Now press enter to actually make it compute. And here's what you get. You get 0.07635 ... And we are supposed to round to right up here, 4 decimal places, all right? So down here at the bottom, 1, 2, 3, 4. That's a 5. In statistical rounding, I always round to an even digit. So I'm thinking 0.0764. All right, so that is the area under this curve. So that right there is that area. So let's report that up here in our picture here. That is going to be 0.0764. Now, problem 7 out of 6.2. Sketch the area under the standard normal curve to the right of 1.62. All right, now here's what this is going to look like. I still have that big, thick font here. that I can't get rid of. Nope, I can't get rid of it. Okay, so now I want to be to the right. Okay, the high point is 0. Here is 1.62. And we want to be to the right. So I need that area out there. So on your calculator, here's what we're going to do. You're going to press second, and then VARS. So second, VARS, and then select item number 2. That's normal CDF. You don't want number 1, normal PDF. You want number 2, normal CDF. And now the lower bound, well, they're giving us the lower bound here, right? They're giving us the lower bound. Where are we? Z, I want the area to the right of Z equals 1.62. So the area to the right, that's over here. So my lower bound is the 1.62. So now type in 1.62. Enter. And now the upper. Right, now the upper, this is, look at the picture up here on the top. Go ahead and paste. Press enter. You know, when you paste, then you get all this stuff. Press enter, and then you're ready to calculate. Now when I did mine, I got 0.052616. Now we want to round off to what? This is part B. Round to 4 decimal places. So down here, 1, 2, 3, 4, and that's a 1. So I'm going to go with 0526. So let's report that. The area to the right is 0.0526. Question number 8 says, let's do the same thing we did in 6 and 7, but now we have an interval, right? So we're going to take a look at this interval right here. So on our calculators, we'll do it completely on the calculator. So we're now going to go to, well, we probably remember how to do this. We're going to go to second, VARS. That's where the distribution key is. So second VARS, and you're going to select number 2, normal CDF, hard to read with this thick font. All right, so you select number 2. Now, here's the lower. I'll just abbreviate it. The lower is this number right here. That's the lower, all right? So you type in that number. Negative, now not minus, be careful, it's negative, not minus, 2.27. The upper, okay, now here's the upper right there. So the upper is 1.33. Now the mean is still 0. Standard deviation is still 1. So you paste. You paste and then you enter, and I got this. I got 0.896637. So to 4 decimal places. How about right there? 8966. So it's 0.8966. Let's just be sure we understand what we're getting here. We got a normal curve. Now the high point is 0, and we're going from negative 2.27 out here up to 1.33, negative to positive. And we're getting this area right here. What is that area? Well, we're saying that's about, what, about 89.6% of all the area under that curve. That's what we're doing.